Okay, in this second unit, again, it's more background knowledge part 2, if you will. We are going to be looking at factoring. Well, today we'll just simply look at factoring. Tomorrow we'll look at even more advanced factoring. We'll look at simplifying fractions, specifically algebraic fractions, and when can we cancel, when can we not cancel. Operations with algebraic fractions, so multiplying them, adding them, subtracting them, dividing them. Solving advanced equations will be our last thing. So we're basically doing a lot of algebra in this unit and making sure you're really solid in these kind of skills. Okay, so today we're just looking at factorization or factoring. There's a couple different examples we're going to look at here, and then I'll make sure that you have plenty of practice doing these. So when we're factoring, the first thing we always want to think is, what do they have in common? So if we look at this example, 5x plus 10, what do they have in common? Is there anything that we can factor out here? And of course, both 5x and 10 are divisible by 5. So we can factor out 5, and we're left with x plus 2. And now this is fully factored. Sum and product. In this method, you're thinking what two numbers multiply to 12 and add to 7. And you'll see this form, x squared plus some coefficient multiplied by x plus some constant. So what two numbers multiply to 12 and add to 7? And we set it up as, we know x times x is going to give us x squared. Two numbers that multiply to 12 add to 7. And we know that's going to be a positive 4 and a positive 3. 4 times 3 gives us 12. 4 plus 3 gives us 7. And to check that, we can expand it again. So we can do FOIL. We can do x squared plus 4x plus 3x plus 12, and we get the original equation that we started with. So this checks. So this is fully factored in this step. The next one is a difference of squares. Notice that x squared and 25 are both perfect squares. And there's a difference of them, meaning subtraction. So if you have two perfect squares and there's a minus sign in between them, you can factor using what's called the difference of squares. So we take the square root of our x squared, which we know is just x. X times x gives us x squared. And then we'll do plus the square root of 25 and minus the square root of 25. Or in other words, plus 5 and minus 5. And again, we can check this by expanding using FOIL, and we should get exactly what we just started with. So if we expand that, we should get x squared minus 25. So this is fully factored in this step. Perfect squares we can factor in the same way that we factored sum and product. In fact, difference of squares, you could do that too. Really what we have here is x squared plus 0x minus 25. And in your head, you can think, what two numbers multiply to negative 25 and add to 0? Well, positive 5 and negative 5 multiply to negative 25, and positive 5 plus negative 5 gives us 0. So it's another way of thinking of it. So perfect squares, in our head, we're thinking what two numbers multiply to 1 and add to 2. And again, we set up x times x, because we know that gives us our x squared. So two numbers that multiply to positive 1 add to positive 2. Well, 1 times 1 gives us 1, and it adds up to 2. We just have one more step to do here. Because these are the exact same binomial, we need to simplify it to x plus 1 squared. So now this is fully factored. And the fact that it's a perfect square is because we've got our binomial squared. You can recognize that because your coefficient of x, like 2 here, will be twice whatever your constant is. But again, you can just think of that in the same way that you thought of your sum and product. What two numbers multiply to 1, what two numbers add to 2, and just make sure you do this final step of squaring your binomial at the end. Okay, then the last one is decomposition. So if we have 4x squared minus 4x minus 3, and we can't just simply factor anything out. We can't factor out the 4 from negative 3, and so we're a bit stuck here. It's not like we can just do x times x to get our normal x squared. So we use decomposition. In our heads, we think, okay, we're going to take the product, which is going to be our negative 3 times the coefficient of x squared, or 4 times negative 3 gives us negative 12. Okay, then our sum is always going to be the coefficient of x here, so negative 4. So in our heads, we're thinking what two numbers multiply to negative 12, hence product, and what two numbers add to negative 4. So two numbers that multiply to negative 12 add to negative 4. And that'll be a negative 6 and a positive 2. So negative 6 times positive 2 gives us negative 12 when we multiply them, and negative 6 plus 2 gives us negative 4 when we add them. So we decompose this negative 4x into those two numbers as coefficients of x, and we keep everything else the same. We bring down our 4x squared, and we bring down our minus 3. So all we've done is used our product and sum to decompose this negative 4x, which is really helpful because now we can just focus on the first two terms here, and we can think in our head, okay, what can I take out of those? What factors out of 4x squared minus 6x? And we know for sure we can take out a 2, and we also can take out an x. So we're left with 2x minus 3. And again, we're thinking in our heads, what can I factor out of 2x minus 3? So we'll have a plus in between. This plus comes down here. And the reality is we can't factor anything out of it, but we can always take a 1 out. So if there's nothing that they share, no common terms, we can always just factor out a 1. So you know you've done decomposition correctly if whatever you have in brackets, whatever your binomial is in brackets, is the same. So now we can factor out our 2x plus 1. So we have 2x plus 1 times our 2x minus 3, because we have 2x minus 3 in both of these. So now our original function, if we were to FOIL this, we would get what we originally started with. So this is our original expression fully factored. So just some practice with that. Letter A, if we want to fully factorize that, notice we don't have any constant added. So in this case, we can just look at it and simply think to ourselves, is there anything I can take out? And that's always the first question you should ask yourself. Is there anything they have in common? Is there anything I can factor out of here? And there is. We can take 3x out of both terms. So we have 3x times x gives us 3x squared, and we have 3x times 3 gives us 9x. So now A is fully factored. Same thing with B. Again, there's no constant term. So in our heads, we're going to think to ourselves, okay, what can I factor out of here? So for B, they simply just share an x. If we take out an x, we're left with x times 2x gives us 2x squared, and x times 7 gives us 7x. I'll let you continue with a couple of those. Letter E is a special one. Notice that 9 and 25 are both special numbers. They're both perfect squares. And notice we have a subtraction sign in the middle of them. So we actually have what's called a difference of squares here. So we take the square root of 9x squared, which is 3x. The square root of 9 is 3. The square root of x squared is x. And we add and subtract the square root of 25. So we'll have plus 5 and we'll have minus 5. And then when we expand that, again, that would give us 9x squared minus 25. So now that is fully factored. Same thing with letter F. Letter F, we have, again, a perfect square of 16 and a perfect square of 1, and we have a minus in between. So we know the square root of 16 is 4, square root of x squared is x. So we have 4x times 4x, which gives us 16x squared, and then we do plus the square root of 1 and minus the square root of 1. Okay. Letter J, let's look at letter J. We're just doing the sum and product method. So we can set it up. We've got just x squared in the front, so x times x. And in our heads, we're thinking, okay, what two numbers multiply to 16 and add to negative 8? So two numbers that multiply to 16 and add to negative 8. And we know that that is negative 4 and negative 4 are going to multiply to 16, and when we add those up, they're going to give us negative 8. But we have to do one more step because those are exactly the same. We have to write it as x minus 4 squared. Yeah, so if you want to continue doing those examples, and then if you could check them on this next page. So go ahead and pause it here and continue to try all of these examples and then check your work on the next page. Oh, we should look at letter H and letter I guess. Letter H and letter I. Okay, so for H, we can take out a 3 from both of those terms, right? So right away we can factor out a 3. We've got x squared minus 3. So even though 3 is not a perfect square, they're looking at this as a difference of squares because we've got a minus sign, we've got x squared, which is a perfect square, and even though 3 is not, we can still write this as x plus the square root of 3 and x minus the square root of 3. Because the square root of 3 times the square root of 3 gives us 3. So anytime you have x squared minus some constant, you can always do x plus the square root of that constant and x minus the square root of that constant. So that's H. And I is very similar. Okay. Just some more practice with decomposition then. So if we look at letter A, if we want to fully factorize that, our product is going to be 2 times negative 12, which is negative 24. 2 times negative 12. Our sum is going to be 5, just because that's the coefficient of x. So in our head, we're thinking, okay, what two numbers multiply to negative 24, but add to a positive 5? And we'll decompose 2x squared plus 5x minus 12 to do so. So this 5x, we're thinking, what two numbers multiply to negative 24 and add the 5? And we've got 8 and negative 3. And we just carry down our 2x squared and our negative 12. Okay, so now we focus on our first two terms, and in our head we think, okay, what can I factor out of those? And I can factor out 2x, so I'll have x plus 4 left in my brackets, and again here we have a plus in between, and we think in our heads, what can I factor out of negative 3x and negative 12? Well, I can definitely factor out a negative 3 and x plus 4. So good, we've got the same binomial inside of our brackets. So we'll factor out then from what we have left, we'll factor out our 2x minus 3. And we'll have that times our x plus 4. So now it's fully factored. And if you could do that with several of the following examples, and then you can just check your work on the next page. So here are those answers. And that's it.